Hello guys, this is once again Vibhor Shukla. Today we will discuss seismic analysis and design of 10-story RC building, in which we will calculate equivalent lateral force using Etabs. So I will go to the file, new model, select user save default settings, click on OK. First step is to define grid dimensions. So uniform grid spacing. In X and Y number of grid lines we are taking 4. In the spacing we are taking 6. We are making 10-story RC building, so number of stories is 10. Typical story height is 3 meter and the bottom story height is 4 meter. Add structural object. In this we will select two-way oriented slab. We will provide 0 hangs, put value 0 everywhere, not considering ribs, providing a dead load of 0.2 and a live load of 0.25. Restraint at bottom will be fixed. This is the plan view and this is the 3D view. Now the second step is to define material properties. So defining material properties, I will change it to all stories and change the unit. Now I will go to the define material properties. Select this American grade of concrete is 4000 psi. Click on add new material. Modify / show material. Name it as I will change the color using default properties. Material we have defined as concrete. Now the third step is to define and assign sectional properties. So I will go to the sectional properties, define frame section, find this property a composite beam, then go to the add new property. Rectangular section we are taking, name it as beam BB. I'll change the color and change the section dimension also. Now we'll go to the property modifiers, change the torsional constant value and the moment of inertia about 2 and 3 axis. Now I will change reinforcement, design type beam, top and bottom bars I'm taking 6. Now going to the define sectional properties, frame section. Now concrete rectangular for the column section. Change the section dimension for the columns. Change the reinforcement. Now I will go to the define sectional properties for the slab section, selecting slab 1. Click on add new property, or you can just modify it, changing the slab thickness to 15 cm. Now for the wall section, modify, change the thickness. You can see all the 4 properties for the beam, column, slab and wall we have defined. Now The time is to assign these sectional properties. Ensure that it is all stories, because these properties will be assigned to all the stories in the similar manner. So I will go to the select object type. I will select the beams. You can see all the beams are selected. Now I will go to the assign menu, frame, sectional property. I will select the beam here, apply and OK. You can see the beam property is applied on all the beams from the base story, the story 10. Now I will assign the column property. So I will go to the select object type, select columns. All the columns are selected. Now I will go to the assign frame, sectional property, select the columns. All the column has been assigned. To check they are properly assigned, go to the 3D view here and just rotate it a little bit and zoom it. You see the beam property is applied along the beams direction and the column is applied along the column direction. So our assigning of beam and column is properly assigned. So I will assign slab. So object type will be floors. Select all the floors. Now we'll go to the assign shell slab section. Select the slab property slab 1. Click on apply, then OK. Slab property 1 is also assigned. Now we have to assign wall. You can see there is no wall here, so we have to create shear wall, or we have to draw shear wall and also assign pier label. So we'll go to the draw menu, draw joint object, or we have to change the unit also here. Ensure that it is all stories. Now we'll go to the draw joint object. In the properties object we have to use plan offset along x and y. So I will put a value here 2 and zoom it. You can see we are adding node for shear wall location. Now 2. You can see we have drawn node for shear wall location. Now the time is to draw the wall. So we'll go to the draw, or you can select from here draw walls. You can see the wall is drawn. Now I have to assign the select the object, pier level also, assign shell pier level, select P1, click on apply. Okay. You see the shear wall also assigned with pier levels. Now we have to define similar stories. So before going that, I will go view, object will apply to all windows. Select here similar stories, because we have to define master story. Go to the edit, modify only story data, make 7 story as master story from no to yes. So we have defined one story. Now we'll modify floor plan from story 8 to story 10. So select cylinder story here. Make sure the plan view is at story 10. Select all the elements. Select object, select all the stories from story 8 to story 10. Go to the edit, shells, divide coordinator intersection with visible grids. Click on apply, then OK. Now delete the corner, this particular slab. In this fashion. Now we have to draw wall here. So we'll go to the draw beam and change this property. Now to draw opening at elevator area. Change property to opening. Now we have to modify floor plan from base to story 7. So we'll go to the view, set plan view to story 7. Draw beam again. Property, this will be this. Again opening for this. Now what I'm gonna do is apply the wall section. Select object type. Select here all stories. Set the plan view to story 10. Select is all stories. The select object type. Select the walls. Go to the assign shell wall section. Select the wall 1. You can see the properties. Now what I'm gonna do is select all stories. Use auto mesh option on slab and wall panels. So I will select all elements and go to the assign shell floor auto mesh option. Now the next step is to assign support. So I will make this one story. Set the plan view at the base. Select all nodes at the base floor. I have selected all the nodes. Go to the assign, join, restrain, select the fixed type of support. Now, now I will assign dead load and live load. So I'll go to the select object type. For assigning jet load on the floor, the slab panels, object type will be floors. Select object type floors for slab panels. Make this all stories. Just select object type, select the floors. Then go to the assign shell loads uniform. Put a value of 0.2. Make the similar stories. Set the plan view to story 7. Now I will assign dead load on beams. Select object type, select all the beams. Assign frame, distributed. If you want to see, you can see the distributed load is applied in the shell load. Now we'll go to the define rule pattern. I will take reducible life, and for live load reduction factor I will use UBC 97 code. Now for the live load, change this to live and put a value of 0.25. Now the next step is to define assign win load case. So I will go to the select this code. Select the UBC 97 and for the in Y direction, Windex, modify lateral load, wind speed will be 90, exposure type will be B, importance factor will be B, exposure from shell objects, click OK. Same for this direction also. Now we have to draw null area at the side of building for wind pressure coefficients. Set plan view to story 10. You want to go to the draw wall. In the properties object, select none. One by one draw null walls. Null wall is created. Now we have to assign windward coefficient to null areas for Windex load case. The view plan view to story 1. Select object type. I will select this lines. Go to the assign wind pressure coefficient Windex. Coefficient CP value will be provided 0.8 and windward. Applying on this part only. Now we have to assign leeward windward coefficient to null areas for Windex load. Now go to the assign, select leeward and put a value of 0.5. Now for wind Y load, select object type, select null lines. Go to the assign windward and wind load pattern will be wind Y, and here a value of minus 0.8. Now leeward, minus 0.5. So this is the wind load we have assigned. Now define static load case for equivalent seismic force. Define load pattern, I will select this NHRP 1997. First of all, I will go to EQXA, modify lateral load. I will select direction and eccentricity, x direction plus eccentricity, ratio 0.005, seismic group will be 1, seismic coefficient will be designed per code, site class will be E, SS value will be 0.45 and response acceleration will be 0.18. Response modification factor will be 5.5 and time period will be defined as calculated 1.47. X direction plus eccentricity. Response will be 5.5. So this E. Click on OK. Now go to this. Modify lateral load. Change the direction. X direction minus eccentricity. Y direction plus eccentricity. Y direction minus eccentricity. So we have designed. Go to define load combination. In default combinations. Click on OK. Save the file. Now go to the analyze. Run analysis. Then initializing, you can see the deformed shape of the building. At anywhere you're taking the cursor, reaching the restraint in the joint element. If you shall start the animation, now if you go to the display, show undeformed shape, and if you go to the load assign at the joint, I will show the event, show loading values, deform shape for the index. So the deform shape for the wind. Forces. Select all the values whether you want to see for dead, live, wind X, wind Y, seismic along these directions. Or if you want you can see all the values here. Or you want to see in tabulated, you can see in tabular form. You want to see frame, for the piers, shell stresses, shell load assign, or the display, show tables, whatever you want to see, beam, column, forces. You can check them here. See for the direct if you want to transfer, you can send them to Excel. Total base reaction, fx, fy, fz, mx, my, mz, xyz. Whatever you want to see, these are the load combinations. Now the next part is to design for the concrete frame. You will select here American code. Now if you want to see the piers, label forces, you can go to the view, set elevation, view at ordinate, 8 meter. You can add value of 10 or put at 8. You can see this only for the piers. Display shear stress forces, whatever you want to see. Shear stresses, like if I want to see, you can see the stress. I'll go back to the view, set plan view. Now I would like to design for concrete frame design. For the design, concrete frame design, view of the revised preferences, the design according to American ACI 318. This is for the American concrete design. Click on OK. Design concrete frame design. Select the design groups, select the all. Click OK, then go to the concrete frame design, select design combination. Select all the design combinations. Then we have to design, start design check. Now then I will go to the design, concrete frame design, start design check. See the results. Just click on the beam or the summary. Here is the design report, beam data, beam name. This is the report. See a column. So this is the way we design concrete frame design for RC building. Now to check the design, display design information. You can see here value. Whatever you want to see, column beam capacity ratios 0.30. shear reinforcement, torsional reinforcing, now I will verify analysis or design match. All the members has been passed, so our design is correct. Now I have to design the shear wall, so set to elevation view at 8. Select this, go to the design, shear wall design, view of the revised preferences, select the design code. Design, shear wall, select design combinations. Click OK in order to design. Start design check. Now go to the design, display design information about PR longitudinal reinforcing. This is the PR story 10, PR1, shear wall design. So this is the way seismic analysis of 10-story building we design, including concrete, beam, column, slab, wall design and the shear wall design. So if you have any queries regarding this particular Etabs tutorial of seismic analysis and design of 10 RC building, so post your queries as your comment. I would like to solve them as soon as possible and share with your friends who are in need of learning this particular softwares. I hope you have learned a lot from this detailed lecture of mine on seismic analysis of RC building, that is 10-story building, including beam, column design, slab, wall and the shear wall design, also how to assign pier levels, how to assign dead load, live load, wind load in different direction and the seismic load in different direction, how to assign them. So this is the most important lecture of Etabs you have seen now. So post your queries and I would likely to solve them and listen them as soon as possible. Thank you very much. Once again, this is from Vibhor Shukla, this important lecture for the civil engineers. Stay tuned with more upcoming Etabs tutorials. Thank you very much.